Hello everyone. Today we are going to understand the concept of standard screens. In solid-solid separation, whenever the particles of a different sizes present in a given solid sample are to be separated, then the first and obvious method of separation considered is separation using screening. Now, in order to have uniformity in the result of screen analysis, the standard screens are used. Now, what is meant by standard screen? That we are going to understand. You must have experienced before studying this topic. If you are in a market and if your family members have asked you to purchase a screen, say you are interested in screening of wheat, you are interested in screening of other food grains, then you ask for the screen, say like please give me a screen for screening of wheat or jowar or bajra. You are aware that the sizes of these food grains varies. Therefore, wherever you purchase the screen, if you ask for a specific screen required for specific operations like screening of the food grains, then irrespective of the place, you will get the screen of some specified openings. On the same line, if the screen analysis is to be carried out, and if that result of that screen analysis are to be communicated, maybe as a part of process requirement, maybe as a part of manufacturing standard, maybe as a part of product specification, if the results of screen analysis are to be communicated, then for such purpose the standard screens are used, and after doing the screen analysis, for the sake of clarity, it is mandatory to specify the types of the screens you have used for carrying out the screen analysis. Now, so these standard screens are manufactured as per the different standards. So once you specify the type of the screen used for screen analysis, and if you are sending your sample to someone else who want to test whether your analysis is correct or not, then if he notice what is the standard you have used or which type of the screens you have used, and if he uses the same screens or same state of standard screens, then he will get the similar result. But if the screens which you have used is not specified, then he may use some other screens and the result of screen analysis will not match. Say for example, Indian standard is based on some different parameters. South African standard is based on some different standards. European standard is based on some different assumptions. And likewise, the American standard is also based on some different assumptions. So today we are going to understand the meaning of what is standard screen and what are the types of the standard screens which are used for doing the screen analysis. Now let us try to understand first the definition of standard screen. So the first and obvious question is, what is meaning of standard screen? What is meaning of standard screen? So the answer is the screens which are manufactured as per the pre-decided standard are standard screens. The screens which are manufactured as per pre-decided standards are standard screens. The screens which are manufactured as per pre-decided standard are termed as standard screens. The meaning of pre-decided standard is that there is definite relationship between area of opening of two successive screens. What does it mean? Say, for example, there are some screens which are arranged in the order of coarsest at the top and finest at the bottom. So say area of first screen is A1, area of second screen is A2, area of third screen is A3, area of fourth screen is A4. So when you manufacture the standard screen, then either there is a fixed relationship between the area of opening of say first screen and next finest screen or next smaller screen. So A1 by A2 is fixed. There is some definite relationship. Or you may say that the ratio of diameter of the first screen and next finer screen will also be fixed. So whenever you manufacture the screen as per pre-decided standard, when there is the definite relationship between area of opening of two successive screens, or you may say that the diameter or openings of two successive screens, then such screens are known as standard screens. And therefore, if you specify during the screen analysis which type of the standard screens you have used for doing the screen analysis, then the result of screen analysis will be same whether you do it or whether somebody else at different geographical location do the screen analysis of that particular sample. And therefore, because of uniformity in the result obtained and for the sake of convenience for doing the screen analysis, the standard screens are used. Now there are different types of standard screens are used. Say for example, There is Indian standard IS 460. WS Teller standard is there. It's an American standard. ASTM standard is there. ISO standard is there. British standard, German standards. So there are different types of the standard screens used worldwide. So mainly we'll be trying to understand about the Indian standard and Tyler standards, but for the sake of your understanding, I will just try to define the criteria for some other standard screens used widely. So let us try to understand it. Now, let us try to understand it in more detail. Say, for example, I am considering Tyler standard. It is also known as WS Tyler standard. Now, what is the basis or what is the criteria used for selecting the size of screen opening as per the Tyler standard? So imagine say A1, A2, A3, A4. So as per the Tyler standard, the ratio of, as per the Tyler standard, the ratio of area of first screen and next final screen is 2. What does it mean? The area of first screen, that is A1, to the next final screen, that is A2. So A1 by A2 is equal to 2. So if openings are circular, so A1, I can, in terms of diameter, I can write it as pi by 4 d1 square. Area of second screen, I can write it as pi by 4 d2 square is equal to 2. Therefore, pi by 4 will get cancelled and d1 by d2 square is equal to 2. That is the ratio of d1 by d2 is equal to root 2. Ratio of diameter of the first screen and the diameter of opening of first screen and diameter of opening of next final screen is equal to 2. So this is the first criteria. The ratio of area of first screen and next final screen is 2, or you can say that the area of the screen coarser than the screen under consideration is double. The ratio of, or you can say, suppose if I can interpret it like this also, the ratio of area, the area of the coarser screen is double than the area of next final screen. So A1 is equal to 2A2. But since diameter is easy to measure, assuming circular opening, I have obtained this relationship, that is D1 upon D2 is equal to under root 2. Now this Taylor standard, second assumption of Taylor standard is it assumes the finest screen. The finest screen generally used as basis is 200 mesh screen. The finest screen used in Taylor standard as a basis is 200 mesh screen. However, whenever the particles are finest in size, then you may use some more finer screen, or for a closer separation you may use some screens in between of a size between D1 and D2, or D2 and D3, or D3 and D4. Intermediate screen can also be inserted, but the basis of this particular Taylor standard screen is generally the 200 mesh screen. So 200 mesh screen, the screen opening assumed is 0.0029 inch. You may write it like this also, 0.0029 inch. So you are aware that screen opening is equal to 1 upon mesh number minus wire diameter. So if you substitute, the screen opening is equal to 0.0029 inch and mesh number is equal to 200, then corresponding to this you will get wire diameter as 0.0021 inch. 0.0021 inch. Right? Now, suppose if I have told you that 200 mesh screen is the finest screen, say this is a pan, suppose this is 200 mesh screen, right? Now what is the size of the opening of the screen above this particular screen? Say if it is denoted by, say, A1, and if it is denoted by A2, then A1 upon A2 is equal to 2. Therefore, we have obtained it as D1 upon D2 is equal to √2, right? Now, please remember, the screens are arranged in the order of coarsest screen at the top to the finest screen at the bottom. So, if we think about the screen opening, then screen opening will be minimum at the bottom and maximum at the top. So suppose if A2 is considered as the screen with 200 mesh size, so its opening is equal to 0.0029 inch. So what will be the opening of the screen above it? So as per the Taylor standard, the opening of the screen above it, that is D1, will be equal to √2 into the opening of the next finer screen. So for next finer screen, I am assuming it as a 200 mesh, and therefore √2 multiplied by 0.0029 inch. So if I do it, then this answer will be equal to 0.0041 inch. So in this way, now suppose if I have considered the screen above it, so what will be the size of the opening of the screen above A1? So that will be equal to √2 multiplied by 0.0041. So whatever the answer comes, say for example, it will be around 0.0058 inch. So in this way, as per the Taylor standard, the ratio of area of opening of first screen to the next final screen is equal to 2. That is d1 upon d2 is equal to root 2. Suppose if more closer separation, if more closer separation is desired, if more closer separation is desired, then the standard used is a1 upon a2 is equal to root 2. That is d1 upon d2 is equal to fourth root of 2. As per the Taylor standard, I am saying, if you want more closer separation, see, more closer means what? 0.0029 inch and 0.0041 inch. If in between 0.0029 inch and 0.0041 inch, if you want one more fractions which will be greater than where the size of the product obtained will be greater than the opening of this screen and smaller than the opening of this screen, means in between 0.0029 to 0.0041. In that case, the standard assume is a1 upon a2 under root of 2. So d1 by d2 is equal to fourth root of 2. So in this way, the screens are manufactured as per the Taylor standard. It is also known as WS Taylor standards. So the example of the screen manufactured as per the Taylor standards in terms of mesh number is 3 mesh, 4 mesh, then 6 mesh, 8 mesh, 10, 14, 20, 28, 35, 48, 65, 100, 150 and 200 mesh, right? So these examples represent mesh number of screens, or say standard screen manufactured as per Taylor standard. If somebody asks you a question that what is the meaning of Taylor standard screen, so your answer is Taylor standard screen is based on the assumption or a criteria that the ratio of area of opening of first screen and the next final screen is equal to 2. That is the ratio of diameter of two successive screen is equal to root 2. Your second statement in the answer will be, as per the Taylor standard, it assumes finest screen of 200 mesh size opening 0.0029 inch and wire diameter is equal to 0.0021 inch. And for a closer separation, we may manufacture the Taylor screen as the ratio a1 by a2 is equal to root 2, that is d1 by d2 is equal to fourth root of 2. Now let us try to understand the screens as per the Indian standard, or what is the meaning of Indian standard screen. Now, as per the Indian standard, the mesh number of screen is equal to or near to screen size or opening in decamicron. Now, what is the meaning of this? Let us try to understand it. Say, for example, screen opening is equal to 1 mm. Now, I have to define this 1 mm, or I have to convert this 1 mm into decamicron. Now, the relation is 1 mm is equal to 1000 micron. And 1 decamicron is equal to 10 micron. And therefore 1000 micron is equal to 100 decamicron. And therefore, as per the Indian standard, the screen with opening of 1 mm is considered as screen with mesh number is equal to its opening to opening in terms expressed in terms of decamicron. So mesh number of screen with opening is equal to 1 mm is equal to 100. So on a rough basis, suppose if screen opening is 2 mm, then mesh number will be around 200. So like this, straight away you can just multiply the opening by 100 for obtaining the nearest value of the for obtaining the mesh number. So as per the Indian standard, the mesh number of screen is equal to or near to screen size or opening in decamicron. So the screen width opening is equal to 1 mm. I have converted mm into micron, 1000 micron. So 1 decamicron is equal to 10 micron. So 1000 micron is equal to how many decamicron? 100 decamicron. And that size in decamicron is equal to mesh number. So mesh number of that screen is equal to 100. Now we have defined the definition of mesh number, and if you use South African standard or if you use European standard, then the definition of mesh number differs and accordingly the standard differs. So suppose if I consider South African standard, so earlier you are aware that we have defined mesh number is equal to number of aperture per linear inch. So as per the South African standard, it is defined as the number of openings or aperture per square inch. So please try to understand the difference. As per the Taylor standards, we have defined the number of openings per linear inch as a mesh number. Here, as per the South African standard, the definition is number of openings or number of aperture per square inch. It's not linear, it's per square inch. There is the European standard also. This European standard is based on the definition of mesh number. The definition of mesh number as per European standard is number of aperture per square centimeter. Please try to understand it. We have studied earlier definition of mesh number as number of aperture per linear inch. South African standard says number of aperture per square inch. European standard says number of aperture per square centimeter. So in this way, there are different types of the standard screens used worldwide. And whenever you are supplying any product or when you are trying to define the screen analysis or particle, see, the basic purpose of doing using standard screen is to do the screen analysis. And the basic purpose of doing screen analysis is to understand the particle size distribution. And therefore, if you are representing the particle size distribution in terms of the result of screen analysis, then while expressing the result, you must mention which standard screens you have used. So if you have used Indian standard screens, then you may say that IS 460 standards test sieves are used. Sometimes standard screens are also known as test sieves, SIEVES, right? So if you suppose if you have imported certain products, or if you have say exported certain products to US, and you have it's in a powder form, and you have represented your result in terms of product size distribution in terms of screen analysis, and if you have mentioned that I have used Indian standard screens for doing the screen analysis, then if the American peoples or that particular organization wants to check whether it is as per the specification or not, for doing the screen analysis, they have to use Indian standard screens only. Then and then only our result and their result will match. So to summarize our discussion, the standard screens are defined as the screens which are manufactured as per the pre-decided standard. So I hope you must have understood the concept of standard screen and why the standard screens are to be used. Just again, the final concluding remarks. Standard screens are used for uniformity in the interpretation of result of screen analysis. Different countries may use different standards. The American standard and the most popular standard screen is Taylor standard screen, WS Taylor standard screen. There is another American standard, ASTM standard screen. Then Indian standard screens as manufactured as per IS 460s are also used. And apart from that, there are British standards, ISO standards, AFNOR standards, DIN standards, etc. etc. The important thing to understand is these standard screens are to be specified, or when you communicate the result of screen analysis, you have to mention which type of the standard test suits or standard screens you have used. Thank you very much for watching the video.